How does alcohol's acetaldehyde cause colon cancer? Imagine enjoying a drink and not realizing that a tiny molecule produced in your body could be increasing your risk of colon cancer. When you consume alcohol, your body breaks down ethanol into a substance called acetaldehyde. This compound is highly reactive and toxic. Normally, your body quickly converts acetaldehyde into acetate, a much less harmful substance, with the help of enzymes like aldehyde dehydrogenase. But in some people, especially those with certain genetic variations, this process isn't as efficient. As a result, acetaldehyde can build up in the body and in the colon, where it can cause serious damage. Acetaldehyde is classified as a Group 1 carcinogen, which means it is a substance known to cause cancer in humans. It can directly damage the DNA in colon cells by forming DNA adducts, which are chemical attachments that cause mutations. These mutations can interfere with normal cell functions and lead to uncontrolled cell growth, a key feature of cancer. Moreover, acetaldehyde impairs the body's ability to repair damaged DNA, allowing genetic errors to accumulate over time. Another way acetaldehyde contributes to colon cancer is through oxidative stress. When alcohol is metabolized, it produces reactive oxygen species, or ROS. These unstable molecules damage cellular components like DNA, proteins, and lipids. This damage promotes inflammation and encourages cells to grow and invade surrounding tissues. The chronic inflammation caused by oxidative stress creates an environment where cancer can thrive. Alcohol and acetaldehyde also disrupt the gut's natural barrier and microbiome. They increase intestinal permeability, often called leaky gut, which allows harmful substances and carcinogens to penetrate the colon lining more easily. This ongoing irritation leads to chronic inflammation, which is a known risk factor for colon cancer. Some gut bacteria can even produce acetaldehyde locally, further increasing its concentration in the colon and heightening the risk. Genetics play a role too. Variations in enzymes like aldehyde dehydrogenase influence how well your body processes acetaldehyde. People with less active forms of this enzyme tend to have higher levels of acetaldehyde after drinking alcohol. This genetic difference is especially common in some East Asian populations and is linked to a higher risk of colon cancer among those individuals. Chronic alcohol intake can also cause folate deficiency, which affects DNA methylation, an epigenetic process that controls gene activity. When methylation patterns are altered, it can activate cancer-promoting genes or silence those that suppress tumors. This disruption in gene regulation can set the stage for the development of colon cancer. Finally, alcohol and acetaldehyde can weaken your immune system's ability to detect and destroy abnormal cells. They influence the expression of immune checkpoint proteins like PD-L1, which can help cancer cells evade immune attack. This immune suppression allows early cancer cells to grow unchecked. In summary, acetaldehyde damages DNA directly, causes oxidative stress, disrupts the gut barrier and microbiome, alters gene expression, and hampers immune defenses. All these effects combine to create an environment in the colon that favors cancer development. To protect your colon health, reducing alcohol consumption is a wise step, especially if you have genetic factors or other risk factors that make you more vulnerable. Always consult with healthcare professionals for personalized advice and screening options to stay proactive about colon health.